Hello guys, welcome to Bugs in Code. Today I'm going to explain a very interesting problem which is night in Geekland. So let's get started. Here is the problem statement and it says that night is at start x and start y position in Geekland, which is represented by an n cross m 2D matrix. Okay, so we have a 2D matrix which is representing the Geekland. Okay, and now we have a night somewhere in the matrix. Let's say uh, like coordinates x and y. Okay, fine. Now in the ith step, okay, so each cell in the matrix contains some points. Okay, so each cell in the matrix are having some points. So let's say like 1, 2 and so on. Okay, now in the ith step, the knight can collect all the point from all the cell that can be visited in exactly I steps without revisiting any cell. What does this mean? It means that, okay, so before that, let's see this particular note. It says that the knight move exactly same as the knight on a chessboard. So how a knight moves on a chessboard? If the knight is at XY position, so it can move 2 step upward and 1 left, or 2 step upward and 1 right, or like this, okay, or like this, or it can move like 2 step downwards and 1 step right or left. Okay, fine. So it is going if it is at this position, then it will move to this particular cell or to this cell or this cell again, these two cell or these two cell. Okay, fine. So these are the possibilities from this particular index. Okay, fine. Now the sum of all the points, because these are the cell that the knight can visit in ith step. Let's say the ith step, it is actually the first step, but let's say it is the ith step. Okay, so in the ith step, there are possibilities that it can visit all these cells. Okay, so all the like points that these cell are having, the sum of those points is going to be the total points that it can collect in the ith step. Okay, so let's say it can collect like p points in the ith step. Okay, fine. So now also the knight has some magical powers that enable him to fetch the coins from the future. Okay, what does this means again? And it is saying that if the knight can collect y coins in the x step, he can fetch all the coins that he will collect in x plus y step. Okay, so like if see this, if the knight can visit p coins in the ith step, so it will fetch the coin from the future from the p plus ith step. This is what this particular line means. And for this particular index, it can again fetch the coin from the future. Okay, and so it will form like a chain. Let me explain you till this part. Okay, so like if I have explained you, like I have Geekland here. Okay, so from this Geekland, I will perform certain steps and I will like move to every cell which is possible. Okay, so let's say in the 0th step I can like collect 1 coin, and the first step I can collect 2 coin, and in the second step I can collect 1 coin, and third one and fourth one. Okay, so now this is 0th step, first step, second step, third step and fourth step. Okay, fine. Now for this like particular step, it can move to like it can ask from this particular index the total number of coins. This is what the problem says. It says that if I have like number of coins as 1 here or x here, and I have the 0th step, so 0 plus 1, it can ask from the 0 plus 1 step. Okay, and 0 plus 1 is the first step. Okay, and for this it can again ask from 1 plus 2 step, which is the third step. So it will ask from this particular step, and it will ask from this particular step, which is 3 plus 1. Okay, fine. So this is how it is going to ask. Now after that, I have to find the minimum number of steps which are required to collect maximum points. Okay, so when this particular fetching from the future completes, then I will have points like 5, 4, 3, 2, 1. Okay, fine. And now out of all these values, for each step I have to return the step where I have the maximum value. So you can see that I have the maximum number of points for the 0th step, so I will return 0 for this particular case. Okay, fine. Now I hope the problem statement is clear to you. Okay, so now I will talk about the solution, but before that, okay, so let's talk about the solution. Here I'm going to divide the solution in 3 steps according to the problem. The first step is collect the coins from each level. and these are the coins that the knight can have without fetching from the future. Okay, so it is like initial state. Initially, how many coins can like knight collect from each level, or I will say each step, for each step. Okay, fine. After that, I will perform the second step, which is fetch coins from the future. Okay, and when this second step complete, then I will have array like the one I have explained you, like this particular array, and this array represent the total number of coins that each step will have after the fetching. Okay, and now at last I have to do a simple task, which is finding the maximum number of coins and the in the minimum step. Okay, now I will start with the first step. How to find like the number of coin for each step? This is the question. Okay, so let me explain you this particular example. It says that initially I'm at this position, so let's call it level 0. Okay, then I will move to these particular positions. These are the possibility for knight. Okay, and I will add all the values for this position. Okay, and whatever is my total sum, that is like the number of points that I can collect for the next step. So if this is 0 level, this is first level for all these values. Okay, so for my first level I can collect like some coins. Okay, and now I will again move to the next level for each like cell. Okay, and then I will again do the sum, and then I will that will be the like total number of points from the second level. Okay, and similarly I will keep moving till I can move uh, like to the levels. Okay, so it is like level order traversal, or you will say BFS. It is like I'm performing BFS, and then I'm like calculating the sum of all the nodes of a particular level. Like if this is the level 1, then I'm calculating the sum of all the nodes. Okay, so till now I have figured out that I can perform the first step using the BFS. Okay, now I'm going to show the example for the second step, because this is really very interesting and important step, which is fetching coins from the future. Okay, let's see one example. Let's see one example. I have an example, and this example uh, so let me first of all let me explain you the first step for this example. For this example, I am initially at this particular cell, and it is having value 1. Okay, so from this cell, as a knight, I can move to this particular index, or I can move to this particular cell. So the total will be, for level 1, the total will be 2. Okay, and for the level 0, like 0th level and the first level, for the 0th level, the value is 1 initially. Okay, now I will move to the next level. So from this position I can move to this index, or I can move to this particular index. Okay, so from this I can move here, and from this cell I can move here. Okay, the total will be 1. So for the second level I have the total as 1. Okay, now from these cells I can again move to, like, okay, so for this cell I can again move to this particular cell, and from this cell I can move to this cell as a knight. Okay, so again I have the sum as 1 for the third step. Okay, now for the fourth step, from this cell I can move to this particular cell, which is this cell. Okay, and for from this I can move to this particular cell. Okay, and this is one cell, so the sum is again going to be 1 for this cell for the fourth step. So this array is representing the one that I have to like calculate using BFS. It is basically the initial state of all the coins that I can collect for each like step. Okay, fine. Now as I have this array, so I can perform my second step, which is fetching coins from the future. Okay, so let me write this step: fetching coins. Okay, so fetching coins from future. Okay, fine. Now let me draw the array again. I'm going to draw the array again, which is 0th step, first step, second step, and I have the third step and fourth step. Okay, and for each step I have the values like 1 2 1 1 1. Now for this 0th step, it will fetch the coin from the future. So if I call the total number of coins for this 0th step is solution of 0, then it is going to be the initial value that I have. Initial value that I have is, if this is like array, so initial value that I have is array of 0. Okay, plus solution for solution for like this particular index. So this is basically since I am fetching from the future, so I have to do like x plus y, which is 0 plus 1. So it is going to be it is going to ask from this particular like step. Okay, so it will ask from the first step. Now why I am calling this solution of 0 instead of calling this array of like solution of 1 instead of calling it array of 1? Because this particular this particular, okay, what I call this, okay, so this particular like step is also going to call like the fetch coins from the future, but till now it has not fetched. If you see here that till now it has not fetched the coin from the future, so it will again fetch the coin from the future. So solution is basically representing coins after fetching from future. So let me even write this thing. I will write this thing that, okay, so it is like solution of I is coins, like coins of ith index, like ith step after fetching. I hope it's clear to you. So whatever is the total number of coins after fetching that this particular index has, it is going to give that much coin to this particular step. Okay, fine. Now so for this it is again going to call like it will be array of 1 plus solution of what, this one is again going to call like the same function, or it is going to ask from this particular index that hey, what is the total number of coins that you have after fetching. Okay, so it will say, it will ask from the third index. Okay, now it will again the 3 will again say that I will first ask from I will first fetch from the future and then I will return to you. Okay, so I will say okay, I will wait till then. So now this third index is going to first add the value that the third index has. After that, it is going to ask from this 4 that what is the total number of coins that you have after fetching. Now you can see that this 4 can't fetch like coins from the future. So it will return 1. It will return the value that it has. It will return 1. Okay, fine. So it is like array of 4 plus, since there is no future, so in that case I'm going to return 0. Keep in mind this particular thing. If there is no future or there is like array index out of bound condition, then I will return 0. So there is no sense of saying that there is no future. It's like array index out of bound. Okay, so in that case I will return 0. Fine. Now it will return 0 and it will return 1, so I will have one value here. Okay, and for this array of 3 is containing one value. Okay, so it will return value 2 as this sum. Okay, fine. Let me change the color. So it will return the value 2. Okay, fine. Now array of 1 is initially having the value 2, so now array will 1 have the total value 4. So even I am going to change the value here as well. So it will have one value, it will have value 2, it will have value 4 now, and now 4 plus array of 0, which is 1, it is going to have value 5. Okay, fine. Now we are done with this as well. We are left with this particular index. We are not done with this index. So now we will do the same for this index. So what we can do is we can call solve for 2. Okay, and it is going to say my solution will be array of 2 plus solve for this 3. Now this 3 will say okay, I will fetch from the future, then I will tell you. But 2 will say hey, stop, you have already done this, so why you are doing the same thing again? This is the problem. So till now you can see that I have figured out two things here, two very important things here. The first is optimal substructure that I am doing here. Okay, so I will write first thing is optimal substructure. Okay, and the second thing is overlapping subproblems. These are the two mandatory condition in order to like call a problem a dynamic programming problem. So since I have the overlapping problem, so I can store the solution to every subproblem somewhere. Then I will like I can call if I have the solution already. I will not solve the same problem again. This is what the concept is. Okay, fine. So this is how the recursive approach looks. Even if I write the recursive relation, so let me write the recursive relation. Okay, so I'm going to write the recursive relation here. Now the recursive relation will be something like solution of I You can relate with what I have explained you. Okay, solution of I is going to be array of I plus solution of I plus array of I, isn't it? This is what I have done. Okay, so this is the recursive relation that we have along with the base condition, like if I of I is greater than equal to, like, okay, if I is greater than equal to array of length, array dot length, in that case it is like the case when I have array index out of bound, so I will return 0. Okay, and one more thing is, if I plus array of I is double equal to I, what is this? It says that if I have condition like 0 and 0, so in that case if I do 0 plus 0, then I can't like move to the next index, so in that case I have to return the value itself, array of I. Okay, so this is how I am going to solve this problem recursively. If you write this code, then it is going to get accepted. But we can also, since we have seen the like dynamic programming, so we can also apply the memoization technique. And this memoization technique says that you will have a dp array, and that dp array is going to say if dp of I is not equal to -1, then I can return that solution. Okay, so this is how memoization works. Let me show you the code. Let me show the code. So this is the recursive code. This is the recursive code that I have. Like, you can relate this code directly to the one that I have explained you here. Now I'm also going to show you one more thing, which is how the first step will is working. Like, I have the BFS step here. BFS step. So initially I'm creating a queue, and before that I'm creating two arrays, which are my moves array. This is going to give me all the possible move that a knight can have like in the chessboard. Okay, so there are total 8 moves you can see here. And now even you can if you see the explanation, then you will find that there are 8 total moves then that the knight can do, like, in a chessboard. Okay, now while my queue is not empty, I'm traversing one level in one go. Okay, so now for this level I'm adding up all the values which are possible, and now I'm simply adding that sum to particular mm, a array list which is storing all the sum for a particular index. Okay, fine. Now I'm converting that to array. This is not a crucial step, but I think it makes problem easier to solve. Okay, now what is this? This is very important, but before that I will tell you something. Okay, so on the right side I have the C++ code. You can see the C++ code as well. So I'm using a pair here because pair makes it easy to work with 2D indices, but this is not the case for like Java. In Java I have to make an int array. Okay, now let me talk about the optimization. What optimization we can do? So the problem with this approach is, problem with the recursive approach is, you can see that when I have the array like 1 2 okay, 1 1 1, so I'm doing for each index. I'm calling the solve function for each index. Like, you can see that this index was not visited in the previous case, so I call the function for that again. So in worst case I have to call the function for each step, like I equal to 0, I smaller than n, and then I will call the same function, solve. Okay, but this is something which is causing the time complexity of O of n square, isn't it? O of n for calling the solve function, and solve function itself take the complexity of O of n. Okay, so we can optimize it. We can optimize it. How we can optimize this? In order to optimize this, we can use the tabulation approach. Even I think tabulation approach is necessary if you want to get rid of the system stack that the recursive function uses, because in any case you can have stack overflow error. Okay, fine. So let's talk about the tabulation approach. Tabulation approach. Okay, so tabulation approach says that if you have array like 1 2 1 1 1, then you will start from this particular point. Okay, so let me even name the steps: 0th step, first step, second step, third step, and the fourth step. Okay, now for this there is no future, so I mean there is no index. Okay, so now their value will remain same for this. Now for this I will say that, hey, what is the value you are having? So it is like asking from this particular index, so I plus array of I, and I'm going to add this particular value to the value that I have in the current index. So it will be array of I plus equal to array of I, isn't it? This is what I will do, so I will make it 2. Okay, fine. Now for this I will check okay, so it is 2 plus 1, 2 plus 1, and 2 plus 1 is asking from this 3. Now this 3 don't have, need to solve for this particular problem because I have already solved this while traversing from this point. Okay, now it is simply going to add this value, so now this value will become 3. Okay, 1 plus 2. Now for this 2 is going to ask from this particular index, which is 3, because 2 plus 1 is 3. Okay, fine. So the value will be 2 in that case, and 2 plus 2 is going to be 4. Okay, fine. Now this one is again going to ask from this particular index, so it is like I'm traversing from the last and I'm doing this particular step for all the values. But before doing this, I will also check if I plus array of I is smaller than like size of the array. Okay, so that I don't go out of bound like for this particular case. Okay, now I hope you are clear with the tabulation approach as well. I just want to show you the code. Okay, so here I have the Java code, and on the right hand side I have the C++ code. Now you can see that first of all I'm initializing my maximum value because I have to keep track of maximum value in order to find the step. Okay, so now in the step here I am merging two steps. The first step is fetching coin from the future, and the second step is keeping track of the maximum number of coins. Okay, so you can see that I am doing the same step that I have explained you even in the C++ code as well. Okay, and after that I'm just keeping track of the maximum and I'm changing my answer index accordingly. Okay, and at last I'm simply returning my answer index. Okay, so this is all about this problem. I hope you guys are clear with the tabulation approach, memoization approach, and the intuition behind the solution. Okay, so this is all about this problem. Thank you.